Assalamualaikum and good day. My name is Nurbatun Amira binti Nur Aslan. I would like to present my final year project, which is grey water footprint determination and prediction of light industrial activities in Kuantan River Basin by deep learning algorithm. The background of my study: water may be an elementary entity for living things. For living things, as there is no living creature that does not rely on water directly or indirectly. The problem statement: in water footprint accounting, grey water footprint is basically being left out. So generally, anthropogenic activities are giving effect to the water bodies, which is the pollution. The objective of my study is to inventarize light industrial activities within Kuantan River Basin area for 2015 to 2017 to determine grey water footprint of light industrial activities in Kuantan River Basin for 2015 to 2017 and to predict the total water footprint for light industrial activity based on deep learning algorithm. So, scope of my study: the area of water treatment plant involved are Bukit Sagu, water treatment plant Bukit Sagu, Bukit Ubi, Sungai Lembing, Semambu, and Panching. My study also focus on light industrial activities such as food production, printing, consumer electronic, and so on. And grey water footprint accounting follow the grey water footprint accounting is referred to the grey water footprint formula, and water footprint modeling that I use in my study is deep learning algorithm, which is the method used is using back propagation. The significance of my study is water footprint trend can be predicted based on hyperparameter. The light industry that use more water to assimilate the pollutant can be controlled. Next, this is the literature review of my study from 2010 to 2019. Next, this is the study area, 5 water treatment plant involved, and this is the project of the methodology. I will explain in detail in the next slide. Okay, this is the objective number 1, methodology for objective number 1. Which is to inventarize light industrial activities. First, we have to inventory data. We have to do the data collection. The data we collect from Department of Statistics Malaysia, PAIP, JPS, and MET. Then we have to classify the data based on type of industry, and then classify into area of water treatment plant. And all these steps we have done in Microsoft Excel. Then the methodology for objective number 2, to determination of grey water footprint for light industrial activities. First, we do grey water footprint accounting. Then we have to classify based on the pollutant parameter. Pollutant parameters that involved in my study is BOD, biological oxygen demand, chemical oxygen demand, COD, TSS, total suspended solid, and ammoniacal nitrogen, ANN. Then we apply grey water footprint formula. All these steps we have done in Microsoft Excel. Next, to predict the water footprint model by deep learning algorithm. we have to do result classifying, data cleaning to remove the outlier, then optimization of hyperparameter, construction network architecture, and training, testing, and validation. We have to train the result to get and testing the result to get the final and testing the data and to get the final result. Before that, we have to validate before the model is published, and we do long short-term memory for time series prediction, and then we can publish the model. This is my result for industrial inventory. So this is what I get for objective number 1. It is stated that the pie chart shows that there is more industrial activities on upstream category for Semambu, and there is more industrial activities in downstream downstream category for Panching. For light industrial activities, there is no discharge for Bukit water treatment plant, Bukit Sagu, Bukit Ubi, Sungai Lembing. There is only in Semambu and Panching. This is for 2015. This for 2016, and this is for 2017. It is same from the previous one. The most industrial activities are in upstream category for Semambu, and more industrial activities in downstream at Panching, the treatment plant. Next, this is the results for greywater footprint according to the type of activities for Panching and Semambu water treatment plant only. Based on the bar chart, it clearly shows that for Panching, the highest greywater footprint is construction industry, and for Semambu, food manufacturing is the industry that use more greywater footprint. This is for 2015. Next, this is for 2016. It is also for Panching construction industry, and for Semambu food and beverage manufacturing. But for 2017, the highest greywater footprint according to the type of activities, the highest is workshop for Semambu water treatment plant. For Panching, it is same from the previous years. Next, this is the result for total grey water footprint for Semambu and Panching water treatment plant in 2015 to 2017. Okay, for Panching, total greywater footprint, the result shows that total greywater footprint is decreased from 2015 to 2017. This is because might be some of the premise have stopped their operation or closed their premise or transferred to other place. But for Semambu water treatment plant, the total greywater footprint is increased from 2015 to 2017. This is due to the industrial activities at this area. Maybe some of the increasing shows that mostly the industrial activities at this area are use more water. So that's why the total grey water footprint is increased. Next, this is the result for my objective number 3. The prediction of grey water footprint using deep learning algorithm. So it shows that for Panching area, the industrial activities show the same pattern as the actual data trend. As you can see there, the green line is the prediction data. So the prediction data shows that it is follow the trending final pattern, and this is due to the industrial activities in Panching is not as busy as Mambu area. So the changes in terms of quantity on a yearly basis is not affected the overall value of grey water footprint. For Semambu area, the prediction values seem in line with the actual data. But the prediction value did not capture the sudden fluctuation. So in deep learning application, the unusual data can be considered as outlier. We can remove from the data, or we can replace by the average value. So this is the reference for my study, and thank you.